All right, we're going to look at problem 1.37, which is further into dimensional analysis. Problem 1.37. So I'm given an equation V equals A t cubed minus BT. So some things we have to recognize in here. Velocity has dimensions of L t minus 1. And this is the same as L t over t. I'll tend to write LT minus 1 as I like having my exponents upstairs so that when I solve for exponents, they're all kind of lined up into one place. So I use the negative sign to give me an idea of what quantity I'm looking for in my dimensions. They're saying the same thing, and we have to get used to mathematics where we can write things different ways because the utility of the notation lets us do different things. Now, if I have units on the left-hand side of L t minus 1, the units on the right-hand side also have to equal LT minus 1. So I have to replace my t units with my t dimensions. And so I have t cubed minus b to the t. Now, there is, in dimensional analysis or any equations, the units on the left-hand side have to match the units on the right-hand side. If you measure something's length, you can't say that's equal to its temperature. Those dimensions aren't equal. And so you can't say, 3 meters is equal to 20 Kelvin. It doesn't make sense. But you can say that, 3 meters per second is equal to some constant times something else if they all come out to be meters per second. Also, because of how addition works, and you can add and subtract from both sides, each term in an addition has to be dimensionally consistent. So we can break this down into two parts. We can say that the first term has to have dimensions equal to LT minus 1. So we can do it term by term. So if we solve for A, I'm going to divide both sides by, I'm thinking out loud, t minus 1 divided by t cubed, which means that I will have L and so minus 1 minus 3 LT negative 4. Sorry, here, looking at my writing, LT to the negative 4. Again, you could write that as L over t to the 4th. I prefer this way for dimensional. I think this textbook wants to see this. We need to realize these are saying the same thing. Sorry about the pause there. So what I was looking for was which way this textbook did this. Now, that gives me A. Well, I can do the same thing over here for B. And so this is part A was what were the dimensions of A. Well, part B is what are the dimensions of B. So I can look at my other term over here. Sign isn't going to matter since we're just looking at dimensions. So we're not asking for the particular values and dimensions. So we want to solve this for B. So B equals L t minus 1 divided by t. So minus 1 didn't stick. There we go. Which is equivalent to L t to the negative 2. And again, in the notation of this book, L over t squared. And so that gets us part B. Now, for part C, it's saying, what are the SI units for A? Well, SI units for length is meters. Oops. Meters. And the SI units for time is seconds. So we can just replace our dimensions, and we can say A is meters per second to the 4th. I want to put an arrow here because this isn't really an equality. And then part D is asking, what are the SI units for B? So we do the same thing. I'll put an arrow. I guess I'll label this A. And I'll label this B. And L is in meters. T is in seconds. So we have meters per second squared. And as we will learn, meters per second squared is a special thing called acceleration. But there we have how we do dimensional analysis when we have an equation. The key is to remember, left-hand side has to equal the right-hand side, and terms have to have the same dimensions. You can't add length to temperature. And that actually stems from the mathematical ideas of equality. If you have something equal, your terms also have to be equal. And we'll look at some more of our mathematical identities as we go. But this helps us solve for these coefficients, and we get an idea of the dimensions for this velocity equation. Technically, you're looking at A would be called something called, let's see, it would be called the jolt, because you have an acceleration, you have the jerk, and then you have jolts, and that's kind of a motion in the time to the 4th power. And the B is actually an acceleration coefficient. And this is what we'll actually start learning next week as we look at what happens when you change position in time. Right now we've got our initial dimensions here, and we can compare